Okay, in this video I'm going to go over a brief introduction to linear equations. And specifically I'm going to go over three different types of forms of linear equations. Now, a linear equation basically is anything that has an x and a y variable in it. Okay? And because it has an x and a y variables, it means we have two unknowns. And when you look at a linear equation, you have basically a line on an xy graph. Okay? Now there's three forms of that line that are actually very, very helpful. And they're called the slope-intercept form, the standard form, which is also known as an Y-Intercept form, and the point-slope form. And what I want to do in this particular video is just go over what each of these three are and show you how you can get from one to the other and show you what some of the uses and advantages of each one of them are. So let's go over just exactly what the forms are. The slope-intercept form is basically y is equal to mx plus b. Now, remember I just said linear equations have two variables, and you're probably thinking, well, wait a minute, these have four. Well, notice that we still have an x and a y, and the m and the b stand for something a little bit different. Now, in order to get the clue on that, go back to the name of the form. Slope, which is the m, and the intercept, which in this case is the b. So let's talk about what that means. The slope is represented by m, okay? And the b, or the intercept, is actually a specific intercept. It's the y-intercept. What would be an example of that? Well, let's go down here for just a second. So here's an equation, or here's a xy graph. Okay. And I'm going to write this equation, y is equal to 2x plus 3. Now, I said this is a slope-intercept form. I said that the 3 represents where it crosses the y-axis or the y-intercept. So you can just go 1, 2, 3. And that point, this line is going to go through that point. Now, what else does it do? Well, we know that the slope is a 2. Now, to understand what that means, notice it's a positive 2. So it means I'm going to be going uphill on this one. And the other way of looking at a slope is what I call rise over run. Okay? Rise over run. The rise is the up and down version. Okay? So rising up or rising down, if you want, if it's a negative number. The run is the back and forth, or along the x-axis. Okay? So if you have a slope of 2, that's really like saying the slope is 2 over 1. That means that your rise from the point that you established is up 2. So you go up 2, and the run would be positive 1, so you'd go over 1, and that'd be like 1. So now you have another point. Once you've got 2 points, you basically have a line. So let's go ahead and draw that in. And there's the line right there. Now notice what I did. I put 2 arrows on either end. That just means that this line extends. So what does that mean? Any point on this line should work in this equation. Let's check that just to make sure, okay? Now we know that this particular point is 0x. So I'm going to put in 0 for x, 2 times that. And it's 3 along the y. So I'm going to go 0, 3. And sure enough, y is equal to 2 times 0 plus 3, or y is equal to 3. Okay? Oh, wait a minute. We actually knew that, didn't we? Because we know that the y was equal to 3. So 3 was equal to 2 times 0 plus 3. There we go. That's what I'm saying. So 3 is actually equal to 3. So it actually works. Let's try another point that we know exists. Let me see. We know that the point, for example, 1, 5 is also another point. We figured that out when we did the slope, didn't we? So let's go ahead and put 1 and 5 in the right spots. So y was equal to 2x plus 3, and let's see if that works. Well, according to this, I know my y is 5, so I'm going to put that in there. I know my x is 2, so 2 times 1, yep, sure enough. 5 is equal to 2 plus 3, which is 5. So again, that point also works. 0, 3 works, 1, 5 works. The point of this is that any point on this line will work in this equation. And again, that's why it's called the solution. All right. Let's move on now to the standard form. The standard form is actually ax plus by is equal to c. This is also known as the Y-Intercept form. And again, let me show you how this works. So here's again my x and y graph. Remember, this axis is called the x-axis, this axis is called the y-axis. Let's come up with a standard form equation. So something like 2x plus y is equal to 4. That would be a good equation. Now, what can you do with the standard form? Well, if you make, I call this the cover-up method, okay? Cover-up method, or the XY-intercept method. If you make x 0, you get 2 times 0. In other words, there's nothing there. That means that your y would be 4. So 0, 4 would be a point on this line. So let's go 0 along the x, 1, 2, 3, 4 along the y. Let's plug those numbers in and see if it works. 2 times 0 plus the y we said is 4 is equal to 4. Does that work? Absolutely, because 2 times 0 is 0, 4 plus 0 is 4. So that actually works. Now let's cover up the y instead. Let's make y 0. Which means I get 2x is equal to 4, or x is equal to 2. So that should be another point on the line. Let's check. 1, 2, and the y is 0, so that would be that point. And here is my line. 2 points, remember, equal a line. Arrow, arrow. Any point on this line should fulfill this equation, would be a solution to this equation. Again, let's check. If I make my x 2, I get 2 times 2, y is 0, and that should be equal to 4. Sure enough, 2 times 2 is 4, plus 0 is 4, 4 is equal to 4. Again, it works on this line. It is a solution for that equation. And again, the line itself is a solution to this particular problem. All the ordered pairs should work. So again, I call this the cover-up method. Make x 0, write it down, solve for y. That's 1 point. Make y 0, write it down, cover it up, solve for x. That's your other point. You now have the x-intercept down here and the y-intercept here, and that's where the name comes from. Okay, let's go to the last form, and that's called the point-slope form. And that is y minus y1 is equal to m times x minus x sub 1. Now, look at the name, point slope. Well, we already know that the slope is m, right? And we also have a point. Now, the point will be here. You will actually put a coordinate, an x and a y, where you have the subscripts. You won't put them here, okay? So let me show you how that one works. Let's do another equation. Here's my x and my y-axis. And let's write an equation in point-slope form. So y minus 1 is equal to 2 times x plus 2. Okay, let's see what happens there. Well, according to this, one of the points is You know, I'm going to change this just to make this a little bit easier for you. Let's make that x minus 2, okay? One of the points should be 2, 1. 2 for the x, y is 1. So over 2, up 1. So one of the points is there. The slope is 2 over 1 again. So up 2 over 1. Here are my 2 points. Let's draw a line. Connect them. And now let's see if any point on this line will solve this equation, okay? Because that's what we said would happen. So let's try that. What do we know? We know that this point right here, for example, is 1, 2, 3 of the x, and it's 1, 2, 3 along the y. Three minus 1 is 2. 2 times 3 minus 2, that's 1. 2 times 1, 2 is equal to 2. It actually works again, right? So any point on this line will work in this equation. That's why I like the point-slope form. As long as you know what one of the points are and what the slope is, you can draw the line. Now, this last thing I said that I was going to do for you was show you how to get from one of these equations, so from the slope-intercept form, intercept, how you can get to the point-slope form from that, and how you can get to the standard form from that. And actually, how one can get to the other. So if you know what one of these lines are, one of these forms are, you can get to the other form of the equation. Let's start with that last one that we did. We started with a point-slope form. We said y minus 1 was equal to 2 times x minus 2, didn't we? Can we change this to a slope-intercept form? Well, let's check. Let's start solving. Let's start using our algebra to figure this out. Y minus 1, let's distribute that 2. So you get 2x minus 4. All right. Let's add 1 to both sides. You get y is equal to 2x minus 3. So I've just gone from the point-slope form to the slope-intercept form. Now, can I get from this form to the standard form? Let's check. Well, the standard form is the x and the y on the same side. So let's subtract 2x from both sides. So I get negative 2x plus y is equal to a negative 3. And sure enough, I now have the standard form of the equation. Now, do all three of these forms represent the same line? That would be the test, wouldn't it? Well, let's check. Let's check. I'll show you how to do that. So here's the x and the y axis. We know that, let's start with this one. We know that the intercept is negative 3, so 1, 2, negative 3. We know that the slope is up 2 over 1. So those are 2 points. Let's draw the line. And now let's check and see if this line fits the information that we know from these two guys. So let's go to this standard form. We said it's the XY-intercept form, didn't we? If x is 0, y would be negative 3. So there's a point. If y is 0, x would be negative 3 over negative 2, or 1.5. And sure enough, remember there's 1, there's 2, and sure enough it looks like it goes through where the point is 3 halves and 0. We just did that one. So this one works. Let's see if it works with this one up here. Well, according to this, we know that one of the points should be 2, 1. So let's go over 2, up 1. Sure enough, there's a point. And we know the slope is 2 over 1, up 2 over 1. Again, it's on the same line. So these three equations all represent the same line, but they're just in different forms, aren't they? This would be the point-slope form for this line. This would be the slope-intercept form for this line. And this would be the standard form for this line. Okay, so I hope that was helpful. It might be a little bit complicated, but I think you probably, if you watch this video a couple more times, you start to see the relationships between the different forms of the equation, and then how you can use each of these equations to actually draw your line over here. I hope that was helpful.